Alrighty, so to start out our new unit 4, relationships and triangles, let's do a little bit of quick review on what you've seen before about triangles. Knowing our classifications and some basic properties on these are going to help us out in our next couple lessons. So don't forget about the different kinds of triangles that we could look at. Now we actually have two different kinds of classifications we could use. So we could classify things by sides, or we can classify things by angles. And so looking at the sides on our possible triangles, we could potentially have a triangle with no congruent sides. We call those scalene. If we have two congruent sides, and we see that marked by the dash marks on those two sides, we call those isosceles. And if we have three congruent sides, we call those equilateral. And if you think about the roots of that word, and just it starts with the sound equi or equal, and so it's dealing with the equal sides. Lateral means having to do with the sides. Alrighty, then classifying by angles, if we have acute angle, so that means all our angles are less than 90 degrees, we call it an acute triangle. If we have one obtuse angle, so that would be the angle down here, that's greater than 90 degrees, we call it obtuse. But notice that the other two angles are definitely looking smaller than 90 degrees. If we're looking at a triangle, and we're about to discover why, we can only have maximum of one obtuse angle. We could have two, or we could have three acute angles. We could also have a triangle with a right angle, and we call those right triangles. Or we could have three congruent angles. And again, you'll notice that all of these look like they're acute angles. And again, we'll look at this back, or look back at this in a second. And we call this an equiangular. And again, usually we refer things to equilateral triangles, but technically equilateral and equiangular triangles are really the same thing. And we'll be discovering kind of why that is over our next couple lessons. So also remember, again, a fact that you probably looked at before, but it's important enough to review, is if we look at the angles in any triangle, they are always going to add to 180 degrees. And this is kind of like your supplementary angles. If we were to actually take this triangle apart and maybe kind of cut off each corner, we could actually line them up in a nice straight line. And you're more than welcome to try that out. If you draw a triangle on a piece of scratch paper, and making sure that you have nice straight lines, I'd use a straight edge or a ruler, then you could actually cut it apart. So each angle, each vertex or each corner is on its own piece of paper, and then try lining them all up along a line so that each vertex hits one single point on that line, and check out what happens. So if we know that all of our angles add up to 180 degrees, then we can actually use that to find some missing information. Just some reminders about triangles and how we might name them. When we're naming a triangle, we want to be very specific and always use all three letters. So we could name this triangle that we have here, triangle ABC, or we could name it any combination. So it could be BAC, it could be CBA, it could be a whole bunch of different combinations. But notice before each one, I'm putting a little triangle symbol to show that this is a triangle. Now, keep in mind the reason I'm doing this is because when we named angles before, we sometimes labeled them with one letter, we sometimes labeled them with two. So there's actually a few different ways we could name our angles in here, and we need to be specific by using the correct symbol to go with it. So we could have angle A from the bottom left corner, but we could also label that as angle CAB, noticing that we've got that A stuck right in the middle of our angle name. We could have angle B or angle CBA or angle ABC. Doesn't really matter what order as long as the B is in the middle to look at angle B. We could look at angle C, which we could also call angle ACB, or angle BCA, as long as the C is stuck in the middle. Our sides technically are segments, so we always need to make sure we name them with two letters. So we could have side AB, we could have side BC, we could have side CA, And again, those could be reversed. It doesn't really matter what order we list those endpoints in, as long as we list both endpoints. Okay, so one of the things that we're really going to need to know this unit, and this might be a little bit new, is being able to identify where things are in the triangle. So for example, we could have the side that's opposite angle A. So if I look at angle A in the triangle, if I go completely on the opposite side of the triangle, I would find side BC. Another way to try to do this is if you actually cover up the other half of that triangle. So let me find my drawing tool. So if I was to cover up that side, you'll notice the only full segment that I can see is segment BC. So that's what's opposite angle A. I could do exactly the same thing if I took that and covered up side B or angle B. That would give me the opposite angle, or opposite side is AC. What would be the opposite side to angle C? Well, that would be side AB. Alrighty, so I can do the same kind of thing. Let me move my thing over. I can do the same thing with what angle is opposite from a segment. So for this one, we're going to look at segment, or what side is opposite, excuse me, what angle is opposite from side AB. So let me change my color for my labels. There we go. So if I'm looking at segment AB, what angle do you think is opposite? Well, I would have to go straight across, and that would be angle C, or I could name it with other, other methods. I could say angle ACB, or I could call it angle BCA. Either way, I've got the C stuck right in the middle of that letter. And I can use the same trick on this one. So if I cover up my segment, then it will reveal the angle that's perfectly opposite. So I need a different size box here. Actually, it's going to have to be a bit bigger. So let's say I'm looking for the side, or excuse me, the angle opposite side AB. So if I cover up side AB, which I don't know that it's going to let me do it with that shape, but try with your hand, hold it up to your screen and just cover up side AB. The only angle you're going to be able to see is angle C. And we can do that with all the other angles as well. So that's important when we're naming the pieces. The other part that we're going to need to know is how to find angle measures in our triangles. And so this goes back to the idea that all the angles in a triangle, in the interior of a triangle, are always going to add to 180 degrees. So if we know 2 of the angles in the triangle, that means we can figure out the third by just subtracting from 180. So let's try out a few. So first example, we're given a triangle, example 1, with 65 degrees, 57 degrees, and we have to find the leftover measure. So again, all we need to do is subtract from 180. So I'm going to take 180, and using whatever calculator you have available, I'm going to subtract to 65, and I'm going to subtract to 57. And let's see what that comes out to, minus 57. And I get 58. So that means my missing angle is 58 degrees. And again, all I'm doing is subtracting what I know from 180 degrees. So same thing I can do for example 2. We're given 40 degrees, and then we've got that box in the corner, which really means we've got a 90-degree angle. So we can do the same thing. Let's just subtract from 180. So 180, take away 90, which would give me 90. Take away 40, well, 90 minus 40 would give me 50 degrees. So my missing angle is 50 degrees. Now, what if some of our angles aren't necessarily inside our triangle? Well, we can still use our idea, all triangle angles add up to 180, but then combine it with some of the other ideas that we used. So in number 3, we're looking for a missing angle, but he seems to be outside the triangle. But he makes a nice linear pair with this start angle. So if I could figure out the start angle, then I could actually find that, what we call an exterior, because it's outside the triangle, we could find that exterior angle. So I'm going to go ahead and find the start angle first. So take your 20 and your 60, subtract those from 180, minus 20 minus 60. Well, let's see, 20 and 60 actually add up to 80, and 180 minus 80 would give me 100. So that's going to be my start angle. So that means what's actually our missing angle if those two angles make a linear pair? Well, that outside angle then is going to be 80 degrees, just using that idea of linear pair or supplementary angles. Okay, let's look at a couple more. Again, we're up in the ante a little bit, but we're still going to use the same properties that we knew about already from previous units. So we know that linear pair or supplementary angles add up to 180. All interior angles add up to 180. And the other pair that we reviewed before that we're going to start seeing more frequently is vertical angles. And vertical angles are always going to be congruent. So let's keep going. Okay, next practice problem. Excuse me, I need to save that. Now I can scroll. Alrighty, so number 4 looks a little bit complicated, but all we need to do is look at one triangle at a time. So I'm going to use that same trick I did before. I'm just going to cover up part of my diagram. So I'm only focusing on one thing at a time. So let's actually cover up the right-hand part of the diagram for the moment. So on the left-hand side, I really just have another missing angle problem. So if I take 90 and 58, add them up, then I should be able to subtract that from 180 and find angle 1. So 180, take away 90, well, that gives me another 90. Take away 58 should give us 32. So I can go ahead and label angle 1. And if you're copying this down on your own paper, I would absolutely take a moment, even pause the video at this moment, and maybe copy down this diagram. So I'm going to go ahead and reveal the other piece. And so if you need to, copy down the rest of the diagram, pause the video if needed. Okay, so now that we know that angle 1 is 32 degrees, can we do anything with that for angle 2? Well, angle 2 is directly across from angle 1, so that means they're vertical angles. So that means angle 2 is also 32 degrees. And then I can use that same trick. In that bottom right triangle now, I know I have 32 degrees, I have 108 degrees, so I can subtract from 180 and find my missing leftover angle. So let's change colors. So on the right-hand side, I can do 180, take away our 108, and take away our 32. So again, calculator time. There's nothing wrong with checking your work on a calculator. I'm left with 40 degrees. So that means angle 3 is 40 degrees. And if you're worried that you didn't find the right value, again, go in for any triangle that you see, add up all 3 angles and double check. Did they come out to 180 degrees total? Alrighty, last problem. Number 5 is misleading. I only have, it seems, one angle labeled. I've got that 68 in the bottom right corner. But I actually know more information. So we have some extra marks on here. First marks that I see are I have some congruent pieces in here. So think back to our different types of triangles. If we know we have 2 sides congruent, what kind of triangle is it? Oh, well, that's an isosceles triangle that you've looked at a little bit before. And for isosceles triangles, we know if 2 sides are congruent, well, shouldn't the opposite angles be congruent? And so if it helps, again, kind of draw in, just pointing to your opposite sides. That's why we practice that. And so not only is the bottom left angle 68 degrees, so is the bottom right. Well, Ms. Burnside, why in the world are you bothering to find something that's not labeled? Well, I found with this, I'm just looking at angle 2 and I don't quite know enough info about it. It looks like it might be half of that 90-degree angle up at the top, but I don't know. So instead, I'm going to go through and find every piece of information I can about the rest of the diagram. Any other ideas on what extra info we could fill in? Well, now that we know 68 degrees in the 2 bottom angles, the 2 base angles of our isosceles triangle, well, we have enough information now to find that top angle. So I'm going to put a star there so I know which one I'm finding. So again, I can take 180, take away the two 68-degree angles that I know about. So subtract those out, and we're going to get 44 degrees. So this top angle is 44 degrees. Now, do we have enough information to solve for angle 2? Well, hey, angle 2, if we're looking at this right angle up in the top of our diagram, angle 2 is only the kind of leftover piece from the 44 degrees. So to find angle 2, all I need to do is 90 degrees, take away 44. And again, if you need to, check your math. And that gives me 46 degrees. And that's really the only angle they wanted us to find, but I had to label the rest of the diagram to make it work. So when in doubt on looking at any of these problems, if you can't figure out exactly what the angle is that they're asking for, label anything else that you can figure out, and chances are that's going to give you enough information to continue solving the triangle. Okay, definitely ask me if you have any questions about this review material. Let me know, pop back into Zoom if you have questions. Otherwise, check out our practice that's posted next.